Greetings and welcome to the review video really on the one sample t-test setup and design. So let me just get this up here right here. So we're just going to do a review on the one sample t-test setup and design. So this term one sample may or may not, be as comfortable because we've been referring to the other two types of t-tests in our family of three t-tests as independent and dependent t-tests, or another name for dependent was paired samples. So let's just go through a real quick review here. So let's just again remember that if we randomly assigned into a group where they were getting a drug A treatment, and then we were making an observation of blood clotting times, and then we randomly assigned another group, an independent group, to receive drug B, and then looked at blood clotting times. The question we have to ask ourselves is how many samples have we taken? Well, if we have n equals 10 here and n equals 10 here, we have two samples of n equals 10. So the large N here is going to be 20. So when we think about this, this is the independent t-test. Now we use the term independent because I'll just switch to a different color here, but group A is independent of group B. The 10 people that are in that are receiving drug A are not the same people as the 10 people that are receiving drug B. Two independent samples, right? And so what you will often hear this also called, instead of an independent t-test, is maybe a test for a two-sample hypothesis. A test to test a two-sample hypothesis. What's a two-sample hypothesis? Well, the null here would be that the mean of group A minus the mean of group B equals 0. So where are your samples here? This is sample 1, this is sample 2. So it's a two-sample hypothesis. Okay, let's go on to the dependent t-test. For the dependent t-test, it can look more like, I'll draw it this way first. So you have maybe 10 that come in and they get a pretest and an observation. They receive an intervention, maybe a weight loss supplement, and then they get their body mass measured again. So you have this pre and this post. So the pre is entirely dependent on the post, and so this is, you have one sample of n equals 10, and we call this a dependent t-test or paired samples. Why is it a paired sample? Because the same 10 people that are getting measured at observation 1 time point are this right here are the same 10 people that are getting measured here. So you're measuring across the row. You're measuring in the same row, whereas in the dependent t-test you're measuring across the rows in this manner. Okay, so you might hear this also called a paired sample. So you have a two-sample hypothesis, paired sample hypothesis, and what does that look like? Pen stopping working here. Let's see if we can get the pen There we go. At the, you know what is actually probably a better thing to do here? To be consistent, I'm going to change this to make it consistent with our parameter. So this should be the mu of A minus the mu of B equals 0. The point estimates for these mu's are these x bars, but this is the correct way to write the actual hypothesis here. So then down here, to be consistent, we've been writing it as the mu of the different scores is equal to 0. So that's your paired sample hypothesis. So now when we go on to the one sample, and you will remember this, we've already kind of drawn it out once in a previous module, but you know, this is essentially now where you have some kind of treatment and you're just making an observation, and then what you want to do is, if this is n equals 10, you want to then test and get a t value that is an x bar based on these 10 individuals being measured at this time point minus some mu, and I'm going to call this a mu that an investigator chosen. This will become more clear, this investigator chosen piece, and when we work out the problem, and then you're going to divide this by the standard error of the mean, which again we know to be equal to the square root of the variance divided by n. Okay, so I mean, the point here is I'm going to go to red, the design for the independent, there goes that button again. The design for the independent looks like this. The design for the dependent generically looks like this. The design for the one sample generically looks like this, with this as our equation that we have to solve for and put into our 5 or 6 generic steps for hypothesis testing. So that is just a quick, again, overview, differentiation, points of distinction between the t-test family here, the independent t-test, the dependent t-test, and the one sample. And so I think it's important here. You know, I guess one of the pieces we didn't mention, let me just do this quickly before we sign off, is that, you know, this is now a one sample hypothesis. So you've got a paired sample hypothesis, you've got a two sample hypothesis, now you have a one sample hypothesis, and it is going to be the null. Generally, I mean, you can do this a number of different ways, but the mu is less than or equal to some, I'm going to say, value here. It's going to take on some number, right? Some investigator chosen number. So quickly, for example, if you measured the age of your sample and you want to know, and the age of the sample, the age of the population was known, and you wanted to see if you could consider your sample to be equal to that of the population's age, you could then kind of test it in this particular fashion. So hopefully that is clear. It will become more clear when we work out the example in the next video. So thanks for watching this video.